Hi ladies, it's Mr. O'Sullivan. Today we're going to be looking at lesson 7-2, Arithmetic Sequences. So today's learning target is I can apply the definition of an arithmetic sequence by finding a specified term and creating my own arithmetic sequence rule. So there are two new words we're learning today, arithmetic sequence and common difference. Arithmetic sequences are ones where the term in the list increase or decrease by the same amount each time. The common difference is the amount that gets added to the successive terms of an arithmetic sequence. If you're struggling with finding your arithmetic sequence, just do this. Use your rule, difference equals a sub 2 minus a sub 1. That is going to work for every single case, as long as your sequence arithmetic. Now you're probably wondering, do I have to memorize my arithmetic sequence rule? No, not at all. The formula is actually provided for you on your reference sheet. You just have to learn how to apply it to use it and find your own rule. So the way it works is the nth term or an explicit form or explicit formula of an arithmetic sequence is given by the formula a sub n equals a sub 1 plus n minus 1 times d, where a sub 1 is your first term and d is your common difference. This is how it's given to you on the reference sheet. I don't write it like that. I write it like this. A sub n equals a sub 1 plus d times n minus 1. I like to write my common difference in front of my parenthesis, not after my parenthesis. It's important to know, though, that arithmetic sequences are linear functions. And the reason why they're linear functions is because they have that constant rate of change or that constant slope. So let's look at these questions. We're given two sequences. Our first sequence is 5, 9, 13, 17. The first question asks, is it arithmetic? So what we need to figure out is it going up by the same term each time? So all we're doing is we're really calculating our jumps. So when I go from these jumps, I want to figure out what I'm going up by. So when I go from 5 to 9, I go up by 4. When I go from 9 to 13, I also go up by 4. When I go up from 13 to 17, I also go up by 4 again. If you don't see that you're going up by 4, just do this. What's 9 minus 5? 4. 13 minus 9? 4. 17 minus 13? 4. So because I have that common difference of 4, it is arithmetic. So yes, it is arithmetic. And we found out our common difference, which is 4. Okay, so we're now going to write our explicit formula. We know our explicit formula can be found using this method, so I'm going to rewrite it. So I'm going to write down a sub n equals a sub 1 plus d times n minus 1. So what this question is asking is for us to identify key information. A sub 1 is our first term. So I go to my sequence, and my first term is a 5. The d is our common difference, so it's what we're going up by each time we say it. Here it's 4, and we also can look above and it's 4. So I have 5 plus 4 times n minus 1. Now, what we're going to do is we're going to distribute our 4. This is totally acceptable. You can stop here, or you can go ahead and simplify. So whenever we simplify, we just distribute. So I get a sub n equals 5 plus 4n minus 4. Now I combine my like terms, and I get a sub n equals 4n plus 1, because 5 minus 4 is 1. And that's your final answer. Now let's go on to our next set of problems. In this sequence, we have the 7, 4, 1, negative 2. The first question says, is it arithmetic? Well, you have to figure out what you're going up or down by. When I go from 7 to 4, I go down 3. 4 to 1, down 3, 1 to negative 2, down 3. So I'm going down 3 each time. So this is arithmetic. And we just found out that our common difference was negative 3. Now if it's arithmetic, write the explicit formula. So again, we're going to do the exact same procedure we did before, where we rewrite our rule. So a sub n equals a sub 1 plus d times n minus 1. And now we fill in our missing information. If we look, we need our first term. Our first term is a 7. Our common difference is a -3. So instead of writing plus -3, I'm actually just going to write -3. And now I do my n minus 1. And again, I just said before, this can be left as your final answer, but it typically makes sense to simplify a little. So I'm going to distribute my -3 to my n and my -3 to my -1. So I get a sub n equals 7 minus 3n plus 3, because -3 times -1 is positive 3. Combine my like terms, 7 plus 3 is 10, so I get a sub n equals -3n plus 10. Both acceptable as your final answer. Let's go into a real-world word problem. There is a stack of logs in the backyard. There are 15 logs in the first layer, 14 in the second, 13 in the third, 12 in the fourth, and so on, with the last layer having only one log. Find the nth term of the sequence by creating an explicit formula. So for this one, we actually don't have the sequence in front of us, so we have to come up with it. So what I'm going to do is I'm basically going to say, well, I know there's 15 logs in the first layer, 14 in the second, 13 in the third, 12 next, and so forth. Now what we need to do is we need to figure out what our common difference is. Well, to go from 15 to 14, I take away 1, 14 to 13, take away 1, and 13 to 12, take away 1. So now I know that my rule says a sub n equals a sub 1 plus d times n minus 1. So when I do that, I know my first term is 15, so I can have a sub n equals 15. My difference is -1, so minus 1 times n minus 1. You can leave it like that, or you can simplify. I'm going to simplify just so you can see the practice. So I get a sub n equals 15. I distribute that -1 to my n and my -1, and I get minus 1n plus 1, because -1 times -1 is 1. Combine your like terms, and I get a sub n equals -1n plus 16. Now, what we're going to do is we're going to go on to part B, where it says how many logs are in the 7th layer. So I want to find out what's happening at layer 7. We know this is our rule. A sub n equals -1n plus 16. So what we're going to do is we're going to plug in 7 for n. So I have a sub 7 equals -1 times 7 plus 16. I type that in my calculator, and I get 9. And that's my final answer. So there's 9 logs in the 7th layer. Now, part C says use the formula to find which layer will have 5 logs. So I know a sub n equals -1n plus 16. And what I really want to do is I want to solve for n. So we know that we want to have 5 logs. So we're going to do 5 equals -1n plus 16. To solve for n, I subtract 16 from both sides of my equation. 5 minus 16 is -11. And then I divide both sides by -1. So n is equal to 11. So the 11th layer will have 5 logs. And that's it for today. Don't forget to complete your Delta Math. If you have any questions, email myself or Miss Townsend.